Now, what we focused on so far is, with the knowledge of what sine and cosine look like, we have done some practice where we're given the equations and then we want to write the graph, or graph the function. But now we want to go the other way. We want to look at an equation, or look at a graph and write the equation. So let's see if we can figure out how to approach this. So we look at this first graph. Now, first of all, we ask ourselves, what do we want to use, sine or cosine? So when you first look at this graph, you're saying, okay, what would be best to model this? Now, the thing is, using sine or cosine, you can use either one. It's just sometimes one would be easier than the other. So it just depends. Now, the way you decide which one to use, you kind of ask yourself, well, what's going to require the least amount of work? Now, if you look at this graph right here, and you look at the base, and by the way, I'm having this goes from 0 to 2 pi. So we have a graph here that goes from 0 to 2 pi. Now, if you look at this, notice this graph has a starting point. It goes up, reaches a maximum, and then decreases, and then back up to where it started. Now, which one, sine or cosine, behaves like that? Sine. Yeah, sine looks like that. Remember, cosine starts up at the top and goes down. But remember, sine and cosine, you can use either one to model this because they just differ by a shift. Or if you have a sine equation, you can get the equivalent graph with a cosine equation by adjusting the shift, the horizontal shift. So looking at this one, is there any part of the graph that jumps out at you? In other words, from looking at a regular sine graph, does this one differ at all?
Yes.
What's that?
It starts at 2.
That's right, it starts at 2. So we could say, well, this graph has a vertical shift of 2. It's been shifted up 2 units. So that's one thing that jumps out at you right away. Now, we observe that, and as we go along, I want to kind of give you techniques that you can use to find things like the vertical shift and the amplitude. Now, as far as the vertical shift goes, one way that you can find that, if you're looking at a graph, you can always find the vertical shift by finding the maximum y value, adding it to the minimum y value, and dividing by 2. In other words, the vertical shift is going to be the average of the max and the min. So in this particular case, notice we have a minimum value of 0 and a maximum value of 4. Divide that by 2 and you get 2, just like we said. We said, yeah, the vertical shift is 2. And we could see that. So we've got the vertical shift is 2. Now, what else can you determine from looking at this right away?
The period.
What is the period?
Wow.
It's 2 pi, right? Because it starts at 0 and goes to 2 pi. So there hasn't, in other words, this graph hadn't been compressed or stretched out at all. It looks like a sine graph that just starts at the 0 and ends at 2 pi. So in other words, it hadn't been stretched horizontally or compressed horizontally. But notice the amplitude is a little bit different. What is the amplitude? What do you think the amplitude is? Yeah, it looks like the amplitude is 2 because notice if you come from the point or the line about which the graph oscillates, you have to go up 2 units to get to the top. So it seems that we can conclude that the amplitude is 2. So the amplitude is equal to 2. And I think we are about ready to write our equation for the graph. What would our equation be? Y equals what? 2. That's 2 sine. Okay, what do we have? We have y equals 2 sine of x, and then what else? What goes on the outside? Vertical shift. plus 2. So there it is. So notice, that was a very simple one to figure out even without much practice. Because it's clear that this is just basically a sine graph that's been shifted up and has been stretched out a little bit vertically. Now, let's just take a minute and look at something. What we're actually doing is we're trying to find the parts of this graph. In other words, we've got, this sine graph has all the whistles and bells. Y equals A sine B quantity x minus c plus d. And really, when we're trying to write the equation for a graph, we're just trying to find those parts, A, B, C, and D. So let's suppose that we approach this graph with this mindset. We're going to find those parts. In other words, we look upon it as just finding individual parts rather than just say, well, what is the equation? Well, you look at it and say, well, okay, I'm going to find D. Always do this. Find the D first and then the A. Remember, D and A first. That's the building blocks, right? D and A. So you find the D first. Now here's the way you find the D. The D is always going to be the Y max and the Y min average. Okay? And in this case, you can see, yeah, we took the 0 plus 4 divided by 2 and got 2. Now, the next thing you can find is the A. The A, and we're going to look at some special cases later, but if you have a graph that's not turned upside down, this just starts here, goes up, just like a typical sine graph, you're just going to take the Y max minus D, and that will give you the amplitude. So look, the Y max is 4, D is 2, so you just get a 2. Then you look at the graph and you can see, well, there are no other shifts going on. The period is 2 pi. There's no phase shift. It looks like what's going on with this graph is it's just been shifted up 2 units. And that's it. Now this graph, all we had to do was find the amplitude and the vertical shift. So there was nothing horizontal going on. We just had to deal with vertical changes. Okay, any questions? Now that's the simplest kind, where we just can see clearly, okay, this graph has just been shifted up and stretched out a little bit. Now let's look at one that's a little more complicated. And this one goes from 0 to 2 pi. I didn't have it labeled, but that's what it goes. Now, first of all, remember, we're just trying to find these parts. Okay? Now, what is D? Remember, we look upon it as we're finding parts, the components of this thing. Okay? Look, we've got negative 2 plus 4 over 2, right? Isn't that right? We take the lowest point, the highest point, and we average them, and it looks like we get a 1. And look, if you inspect this graph, notice it does look like it's been shifted up 1 unit. Doesn't it? That's right. D is the vertical shift.
Okay.
Now, once we have that, let's find the A. The A, remember, is going to be the max, which is 4, minus D, so we get a 3, right? Well, look at this. We've got half of what we need. We've got the vertical stuff taken care of. Now, look at this. This graph, clearly, something has been done to it horizontally, right? Because we start here at 0 and we go to 2 pi, and we have more than one cycle. How many cycles go on here? That's right, 2 cycles. Notice we start and we finish about halfway through, and then we make a complete second cycle. 2 cycles get done between 0 and 2 pi. So what do you think B is? Now, when B is 1, you get one cycle done, right? What do you think B needs to be to have 2 cycles completed in a 2 pi? That's right, 2. B is going to be 2. In other words, we're looking at between 0 and 2 pi. If B were 1, if we just had sine x, then we would see just one cycle. Well, if B is 2, we'll be seeing 2 cycles. Now let me just show you how we can, let me show you why this is so. Remember that we talk about the period being 2 pi over B. Right? 2 pi over B. And, okay, so we've got period equals 2 pi over B. Now, let's just cross multiply and get this other relationship that's going to be handy for us. B is equal to 2 pi over period. Okay? Now, what do you think? What do you think the period of this graph is? How long does it take this graph to make one complete cycle? Pi. That's right, because it looks like it makes 2 in a 2 pi period, right? So I believe the period there is pi. So here's what we've got. B is equal to 2 pi over pi. Is that right? Pi, that's right. So that just equals 2. So it looks like now we've got our B.
Why?
Why do we have the 2?
Why is it 2 pi over pi?
Well, because we determined that was the period. We could see here that this graph made 2 complete cycles between 0 and 2 pi. So we concluded that it would make one cycle between 0 and pi. Okay, now, look at this. There's the B. Now, let me show you something. Whenever you're looking at a graph and it starts at 0 and goes to 2 pi, and you're trying to write the equation, in general, you can do this. You can just count these humps. Notice, there's 1, 2, and that's going to correspond to the value of B, because that will tell you how many cycles is made from 0 to 2 pi. Now, on to C. It doesn't appear that there's any phase shift, any horizontal shift here, right? Because it looks as though this graph has simply been raised up and stretched out a little bit. So, in other words, it doesn't look as though it's been moved to the left or right. So I would say we're safe in assuming that C is 0. So here is our equation. Tell me what to write. Y equals what? Okay, 3 sine. And then what goes in the parentheses? Okay, 2x. And then what? Plus 1, right? Okay, so we've got... Now notice, all we did, we just found each part in turn. Each individual part as we came to it. Okay, and before you knew it, we had the whole equation.
I don't understand the relation between C and the clock.
Okay, now let's look at this one. This one gives us the opportunity to find A, B, C, and D. Now, up until this point, we've not worried with the phase shift at all. So, we've got to figure out how to deal with that. Now, first of all, what is D in this one? What would D be? How do you find D?
Vertical shift.
Right, it's the vertical shift. Remember, we take the low point, add it to the high point, and divide by 2. I believe we get 1, right? Is that right? Always do this. Sometimes it's not as easy to see, but remember, the D can always be found by the average between the lowest point in the graph and the highest point. So I just take the -2, which is right here, and the 4, average those, and I get a 1. That is D. Now what about A? 4 minus 1 is 3. Because see, 4 is the top point, and then it oscillates about 1. Now, let's just take a minute and look and see what we're saying about this D. What we're saying when we say d is equal to 1 is we're saying that this graph oscillates about this point. Not this point, but this line. And it looks like it does, doesn't it? I mean, if you draw a line at 1, y equals 1, yeah, it looks like. And look at the amplitude. 1, 2, 3, goes up 3. 1, 2, 3, goes down 3. Everybody see that? Now look, we're halfway there. We've got D and A. Now we just got to find B and C. What is B? Well, what is B? Just look at the graph. What is B? 2. B is 2. Remember, all you've got to do in general is just count those humps. And look, here's 1 and 2. Oh yeah, that's right. This goes from 0 to 2 pi. Okay. Does everybody see that? Now for the C part. Now here's something that we're going to do a little bit different. Remember I said you can either use sine or cosine to model these graphs. When you're given a graph with a phase shift, and that phase shift has a labeled maximum, like in this case this one does, the easiest thing to do is the cosine. Because look, normally cosine starts, before it's shifted, here at 0, it starts up here at a maximum point. And then it immediately goes down. Well, this graph doesn't. This graph starts over here at this maximum point. I mean, in other words, it looks like the maximum point, instead of starting here, you can look upon this as a cosine graph that's been scooted over to right here. Well, that's just a horizontal shift. In other words, I'll just say 1.8326 is my shift. That's what I'll say. So I'll say this. I'll say, well, C is equal to 1.8326. Let's just do that. And that will work. Okay, so here's what we have. We have y equals, that's right, 3. Now cosine, B is 2, then x minus 1.8, let's see here, 1.8326, and then what goes on the end? Plus 1. And this, if you put this in your calculator and set your windows as I have them up here, to go from -5 to 5 and then 0 to 2 pi, put that function in, you'll get this graph. It will look just like it.